we're going to be going into this panel called ZK is the Endgame. We have Mihailo, Justin, Uma, actually Mihailo from Polygon Labs, Justin from the Ethereum Foundation, Uma from Succinct again, Togrel from Scroll, Jordy from Polygon ZKVM, and Bobbin from Polygon Maiden / their awesome Grim Reaper icon. All right, so if we can take down the slide, I'll pass it over to Mihailo, who's going to be moderating this panel. Mihailo, go ahead.
Thanks, Hudson, for resurrecting me. I promise this is the last time you will see me on this event. Hi, everyone, again. Mihailo, co-founder of Polygon. And for this panel, I'm joined by 5 gigabrains of ZK. And we're going to discuss why ZK is the end game. So the title of the panel might be a little bit audacious. Some people at least might find it that way, or a little bit kind of bold, or maybe even controversial. But we were smart and we invited only people who generally agree with this statement. So this should be a smooth sail, hopefully. So I'm joined by Uma from Succinct, Justin Drake from Ethereum Foundation, Togrel from Scroll, and Bobbin and Jordy from Polygon. And yeah, guys, can you quickly first introduce yourself? And if you can think of one funny or interesting thing about ZK or your journey in ZK, or something that people can find interesting or funny. I guess ladies first. Uma, over to you.
My name is Uma. I'm one of the co-founders of Succinct, and we're building core infrastructure to try to make it easier for anyone to use ZK. Most recently, we launched SP1, which is a ZK VM that lets anyone write Rust and then use get a proof. Funny story. Oh yeah, one day I think when at the beginning of when I was doing ZK, I think I spent a week debugging something. Actually, it was with CirCom, which is what Jordy, the library Jordy had written. I was debugging something in CirCom. I think at the time CirCom didn't have print statements, and I spent a week debugging something that ended up being like a 1 line of code change that fixed my problem.
Okay, awesome.
I'm really sorry, Uma.
No, it wasn't your fault. It was my fault.
Okay, Justin, do you want to go next?
Sure. Justin Drake from the Ethereum Foundation. I guess funny story. Like I think Snox got me into Ethereum research. It was one of the first things that I really wanted to scratch as an itch, as a Bitcoiner, kind of understand how they work. And I emailed Elie Ben-Sasson, and he invited me to a conference where Vitalik was there, and I remember having this discussion with Zuko and Vitalik, and I think that kind of laid the groundwork for me to eventually join the Ethereum Foundation. I'm also extremely bullish on ASICs for Snog proving. I guess I was a little too early, maybe half a decade too early talking about them, but now they're starting to materialize, which is lots of fun.
Awesome. But you're going to be remembered as a pioneer on the bright side of ASICs.
I don't know about that.
Okay, Togrel, over to you.
Yeah. Hello, my name is Togrel. I'm a contributor at Scroll. We are a ZKVM rollup building on top of Ethereum. Funny story about ZK. I think the first time I've ever learned about ZK was back in university, and I wasn't really familiar with cryptography at the time, and my first assumption was, oh yeah, it's some kind of a mathematical structure that doesn't require any knowledge to actually use it. But then obviously after spending some time in crypto and in computer science in general, I realized that yeah, you actually need a lot of knowledge to work with zero knowledge proofs.
Awesome. Bobbin.
Hey everyone. I'm Bobbin from Polygon. I'm specifically leading the Polygon Maiden effort, which is different role, but still very much part of the ag layer, the different execution environments, so to say. Funny story about ZK is that I remember, so like I think maybe almost a couple of years ago now, I put together some puzzles for ZK Hack. And as part of the putting together puzzles, you want to put some bugs in there so people can find them. So I put in a bug in like missing constraint bug, for example. And then, people found the bug, but then people also found bugs that I didn't intend to put in there, which got in there by mistake. So that was pretty funny that people found more bugs than I intentionally wanted to put in there.
Okay, awesome. And last but not least, Jordi.
Well, yeah, I'm Jordi Bailina. I'm the technical lead at Polygon ZKVM. Fun story, well, as mentioned before, I also created Circum back in 2017 or something like that. Actually, Circum was, I built the first version of Circum in a weekend, mainly to learn how ZK work. Actually, I spent more time trying to understand Vitalik's paper, Vitalik's blog post by the time, that writing Circum itself. I mean, the first version of very sketchy, just to learn on that. And well, after just some iterations on that, I remember one guy, and it's funny that a random project that they wanted to build a mixer using Circum. I just tell guys, this is just, was not ready for doing any production ready. I mean, if you are crazy and you want to do it, it's up to you. But even that, I get a lot of concern. I mean, this project was called Tornado Cache by the time, and I remember that. I mean, they launched it. There were some bugs in Circum. They hacked themselves. They fixed, and it was this is how Tornado Cache was, and was one of the first projects that using Circum. Right now, Circum is quite. I would say it's quite a standard in the space. Probably the technology is getting a little bit old, especially with the newer Starks and all these new proving systems. But yeah, that's a little bit how I started in the space on the ZK part.
Very nice. Thanks, everyone. I will say my interesting, funny / embarrassing story just to make everyone feel better. So back in the days, in 2017-ish, when I was going down the rabbit hole of blockchain infra for quite a while already, but ZK specifically, and I remember, among other posts, Justin Drake's posts from back in the day, Medium posts about ZK. Maybe you don't even remember them, Justin, anymore. But anyways, I got some kind of a brave idea or opinion that I can fully understand snarks. And I kind of invested like a week or so into that effort. And then I just definitely gave up and said, okay, this is not for me. Starks, I can still kind of wrap my head around, but yeah, I just realized that there are limits to things that I can understand. So that was very humbling experience. Yeah, with that being said, going back to the topic of the panel, why ZK is the end game? In my opinion, I will put that kind of as a intro statement, it's because ZK is the only technology in our industry that seems to have the potential to solve basically the major challenges of this industry and major kind of obstacles on the path of becoming or going mainstream, and addressing or being utilized for some of the most important use cases. Like genuinely, there's no other technology like that in the industry. So I would just name a few of these challenges and use cases, and maybe we can go into them one by one. So the obvious and the most kind of explored one at the moment is scaling. Then obviously privacy, because that's kind of the original use case for zero knowledge cryptography. Then interoperability, decentralization, identity, and beyond. Basically, the list goes on. But I would say these are the main kind of the main topics that the industry is focused on at the moment. So let's start with scaling, and I would maybe hand this over to Togrul. And Togrul, if you can give us basically kind of an overview of why ZK is so interesting for scaling, and then others please chime in. Maybe we can go through this together. Togrul, sorry, you're muted.
Compression functions, which just allow us to compress many different. Oh, can you hear me now? Yes. So what I was saying was, I think from the perspective of scaling, you can see zero knowledge proofs as a sort of a compression function that allows us to compress different things. So in case of validity proofs, we compress execution. We can also compress data. So rollups also use zero knowledge proofs to compress data. And that is a lot of different things. So for example, you can use ZK on a consensus level to prevent, if we have real-time proofs, to prevent re-execution of transactions, of the ordering, and basically speed up a lot of things. And you can apply ZK in a lot of different facets of distributed systems and just optimize things and make them run faster and consume less resources. And basically, again, we go back to this end game of having a few powerful nodes doing a lot of computation, and everybody else having these light or stateless nodes that can just verify things and interact with everybody else without having supercomputers or even high-end consumer grade machinery at home.
Okay. Does anyone else want to add anything or pick up on the topic, or we move to the next use case? Okay. I think, yeah, use of ZK in scaling is very much explored at this point, and you guys at Scroll are doing a great job, obviously. So let's move to privacy. I know at least two persons here very passionate about the topic, so I would hand it over to Bobin first, and I'm sure Jordi also would like to chime in, but others also feel free as well. So ZK and privacy.
Yeah, I think, I mean, it's very difficult to imagine how you would do like a very, user-friendly and at the same time private kind of system without ZK. I think like for simple payments or something like that, maybe you can solve it without like hardcore ZK, where you can use like El-Gamal encryption or something like that. But as soon as you try to do something more complicated that is actually maybe useful for the user to maintain their wallet, I think without having ZK proofs, or without actually people being able to generate ZK proofs on the client side, it's going to be a way like, I don't even know how we would do it. So without ZK, in my mind, there is, we can get to like, this pseudo-anonymity that, let's say Bitcoin started out with, and maybe you can add a few more features. But if you want to have like, a user wallet that is able to execute some logic on the client side and, interact with the rest of the chain, like in a composable way and all of that stuff, you do need ZK. There is no way around it. I think, and in general, like I think this is a very important aspect of blockchains that we want to like. I know right now a lot of people are focusing mostly on scaling, but I think privacy is very crucial in my mind for the user adoption in the long term, because we want to have a situation where people don't reveal, balances of their accounts, or it's not easy to track them, and all that. We want to have this the world where, it's better than what you can get with a traditional kind of banking system, and it's not kind of like you have to make trade-offs where, like, yes, you can do it in a censorship-resistant way, but then you have to give up a big part of your privacy and all of that stuff. So I do think, like, if we want to bring in billions of users into blockchains and crypto, you have to have privacy, or at least some way of addressing the privacy kind of limitations of what we currently have. And I think obviously privacy is a very kind of like charged topic in ways, especially around regulation, because obviously Tornado Cash and others, it's very difficult to kind of please everyone on that front, and we need to figure out, and hopefully over time there will be more regulatory frameworks around like what is kind of acceptable and where we want to push the boundaries a bit more. And we want to, but I don't see how like we can stay in the current state without actually getting to price, and ZK is the only way to do it. I also do want to say that like one thing about scaling, which it's kind of related to privacy, is where you can actually generate proofs on the client side. This is a very interesting, like where it's a stateless kind of like you can think about stateless wallets where you only put commitments on chain, but you actually run your logic of a smart contract or your wallet on the client side, which both helps the privacy and scalability because it naturally offloads what what the network needs to do on your behalf. It just needs to verify a proof of your transaction, you get both privacy and scalability that way. And in my mind, like only ZK can offer it.
Okay, awesome. Jordi, do you want to add something? I think you want to add something.
Well, yeah, I mean, it's we live in a world that we communicate a lot. I mean, we are sending in internet, we are sending a lot of information around, and we prove almost anything about the information that we are sending. So the ZK is actually what helps is okay. Let's give away just the required information. So it's like it's not about hiding; it's about sending just what the information that's required, and this information be proved. We have, authenticated. It's a valid, it's a trusted information. So ZK, it's a technology that allows to go in this kind of world where we are more in control in the communications that we are making, and that the communication that we're receiving, the information that we're receiving, is more trusted, is verified, is verified information. Of course, this is very the beginning, and this is very theoretical. But the ZK is the tech that allows to go in that direction. Thinking about privacy, I mean, yeah, I know that's a little bit controversial, but I mean, all of us, we need privacy. I mean, we don't want to reveal all the information to everybody. I mean, it's like we want to control what information we want to give away, and we want to also prove that this information comes from a trusted source. And this is, I mean, ZK helps here and can help some a lot.
Yeah.
I would agree with Sergio. Actually, maybe a better name is that ZK gives you the power to selectively disclose only what you need to disclose, rather than like having to disclose everything. So ZK is the technology that privacy is too broad of a term, but a selective disclosure may be a better term.
Yeah, makes sense. Anyone else wants to chime in on this topic? Yeah, a small comment from my side. I think, as Jordi said, the privacy topic is a little bit controversial now, given all the regulatory scrutiny or unclarity, at least. But as Bobin said, I think it's really important to understand if we want to take this industry mainstream, we really need to have privacy. Privacy is a strong requirement, both by retail, by end users, because it's kind of a basic human right? And that's how traditional financial system works. If I'm using Venmo and I'm sending money to other people, of course, no one will see my transactions. That's how we already that's how things already work. And on the corporate enterprise side, enterprises have business requirements, legal requirements to not disclose data, different types of strategies, and all sorts of things. So yeah, again, long story short, privacy is definitely a strong requirement. I would say if you're thinking about taking this industry mainstream, that's something that really should be understood, I guess. With that being said, I think we can go to interoperability. Uma, I would hand this one over to you because you guys are doing great work on the interoperability, ZK-powered interoperability side, and there are already two concrete outputs of your work that we are learning from and we're going to utilize. One is the ZK consensus that we are probably going to use for the egg layer and plugging POS chain into it, and the other one is your work on the shared validity sequencing that pretty much inspired the whole concept of egg layer, at least to a certain extent. So yeah, great work that you guys are doing over there. And can you maybe shed some light and share some thoughts on this topic?
Yeah, I think at Succinct we've done a bunch of work on ZK bridging, and basically kind of like helping connect all these different chains and all these different ecosystems, utilizing the power of ZK. I think ZK is really nice because it provides this like simple primitive that you can kind of rely on, and then know that, for example, the validators of some layer 1 or whatever have signed off on like a certain state. And so you can just get this like cryptographic proof or cryptographic truth that like some action happened, and you don't have to like worry about all these like trust assumptions like multi-sigs or intermediate chains or whatever. You can just like go direct kind of to the source and verify claims in like a very computationally efficient manner. I also think the work, Polygon is doing with the aggregation layer and ZK is uniquely enabled by ZK because now you can have this like really fast interoperability between all these different rollups. And I think for the end users, hopefully that's like very simplifying. I think if people like try to use L2s today, it is like a very arduous experience because, you know, the chains don't talk well to each other. You have to like use these third-party bridging protocols, and hopefully ZK can move us to a world where, you know, you can get like very instant or close to instant bridging, and you don't have to like worry about this like complicated set of infrastructure on top. I think ZK is like very simplifying in that way. So I think that's why it's very important for interoperability.
Totally agreed. Anyone else wants to add something or chime in?
Yeah, I'm especially interested in this interop at the L2 layer. Like if you try and bridge between two L1s, there's like these fundamental constraints. You don't have shared security, and you can have one chain reorg but not the other, and it becomes a bit messy. But if you work at the L2 with rollups, you can have a system which is extremely clean, where in some sense you don't need bridges, and I think the near people call it on-bridging. And Snox is one of two pillars required to achieve this on-bridging vision. The other pillar is shared sequencing. So once you have two or more rollups that share a sequencer, and you have real-time proving, then you're in a position where you can do real-time settlement, and now you've unlocked synchronous composability across this these rollups. Now, one of the, I guess because we're talking about Snox, one of the valid questions is, do we have this Snox technology today? Like, can we do real-time proving on the order of tens of milliseconds or maybe 100 milliseconds? And even though we don't have it today, I think we'll get it in relatively short order, given the progress that I see Jordi's shaking his head, and so is Mikhailo. We have Axial already that came up with a Snox ASIC, and we also have SciSIC and Fabric that are also targeting an ASIC for 2024. And I think folding is also one of the key ingredients to get there, where you can do like massively parallelized proving, and therefore bring the latency down to a minimum.
Yeah, makes sense. Thanks, Justin. From our side, when we started Polygon back in 2020, we intentionally started as an unopinionated kind of platform, and we still were exploring both optimistic or fraud-proof based scaling solutions and ZK-based scaling solutions. And relatively soon after that, within 6 months or to a year, we developed a strong conviction that ZK really is the go-to technology. And that's when we published our ZK thesis and committed this huge amount of funds from our treasury and went all in basically on ZK. But why am I saying this? When we made that decision and developed that conviction, we mainly were considering advantages when it comes to scaling specifically. So building fraud-proof based L2s and ZK-based L2s, and they are these kind of differences are very much explored at this point. Capital efficiency, the fact that you can immediately withdraw funds, no need for additional party that will submit fraud proofs, etc. Not to repeat that all those things that have been repeated so many times. But what we another very fortunate realization that came later was were the advantages of ZK when it comes to interoperability. So seems like in fraud-proof based systems, in multi-layer 2, fraud-proof multi-layer 2 environment, you simply cannot achieve that level of integration, that level of unification that ZK allows. It seems like it's simply not possible. So that was another very important and very fortunate realization that we had after we went all in on ZK. So yeah, just basically from my side. Okay, the next topic is decentralization. I would like to hand over this one to Justin. And yeah, Justin, you have been exploring different applications on the core protocol or L1 level, like light clients, fast syncing with ZK, all these things. So if you can maybe chime in, maybe improvements on the consensus side, and just basically an overview of how ZK can help improve this decentralization by being used on the core protocol or L1 level.
Right. I mean, the TLDR is that we can snockify everything. And I say that's what it's called in Vitalik's roadmap. So we can snockify both the beacon chain and the EVM. And so what that means, for example, is that if you're currently running a Geth node or whatever it is, a ref node or whatever execution client, you won't have to in the future. And the reason is that you can just be told what the state root is or whatever piece of state you're interested in, and you'll be given a SNOC proof that it is correct. And so the hardware requirements to run a node go way down. And that's relevant for entities like validators, especially if you're a solo validator. And the vision that I have is that you'll be able to validate on your smartwatch. So you're kind of walking around in your town or village, and you have your validators on your smartwatch. But yeah, it's not only for validators, of course. It's for any application that needs to know what the state of Ethereum is. And so if you have a decentralized Uber or decentralized Airbnb or whatever application, and you need to know what the state root is, then you can have these light clients know the state with essentially like zero resources, minimal in terms of bandwidth, minimal in terms of compute, and like no disk IO, no nothing. So in terms of the path to get to this end game, I think what we're going to see is permissionless innovation that happens without any hard forks. So anyone can just try to snockify the beacon chain or try to snockify the EVM. And we're actually starting to see that in 2024. And then once we have sufficient confidence in the infrastructure, so we have multiple implementations, we have hardened those things, we've done lots of audits, then we can consider enshrining it at layer 1. Yeah.
Okay, awesome. Anyone else wants to chime in?
I think one thing that is interesting, and this is more about like decentralizing, let's say, proving a block production on layer 2s potentially, is that right now we have like a single prover that like builds the proof. But in theory, we could like, and maybe that will require some changes, but you could say, you could, and the way that it's done, you have a bunch of transactions and you roll them up into kind of recursively aggregate them using ZK proofs. But it would be interesting to see if you can kind of like decentralize this roll-up process so that, like there's a batch of transaction that is being proven in one place, kind of like block building, and there's another batch that is being built by another actor, and then the final block producer just takes about, the final few batches and puts them together into a block. And like the actual proving is decentralized across network as well. It's an interesting thing. I haven't like fully thought it through, but it's something that I'm very curious if we can make it work.
I think that intersects with what Justin is interested in at the moment quite a lot. Sorry, Justin.
Yes, but there is a bit of a trade-off here, which is that if you want synchronous composability with one shared sequencer, then you actually have to do the proving in real time. So imagine that you have some sort of super transaction that wants to go in and out of rollup A, but also in and out of rollup B. Well, now you need to have the proofs in real time. And so as soon as you start decentralizing the proving, then you lose this real-time aspect. So I think that is a real kind of trade-off of shared sequencing, is that it's not as friendly to decentralized proving. But the way that I think of decentralized proving is as a fallback in case the primary sequencer, or whatever it is, stops working. So in particular, you can use these decentralized provers to build L2 blocks that get included in inclusion lists. So for example, if there's censorship, that's fine. You have a slightly higher latency system that brings these transactions on-chain via the inclusion lists.
But I think like the real-time proving is not too far off. It may be, it's probably not this year and maybe not next year, but it's certainly in my mind within like 2-3 year time frame where we can get to, very close to real-time proving.
Yeah, I mean, even our latest release of ZK EVM it has already per transaction proofs, right? We are still not talking about real-time proving, but it's relatively close. Depends on basically what is your reference. But yeah, I agreed with Bobin. And also one thing, do we need real-time proving for all the transactions, or we only need them for cross-chain transactions, right? So we still can prove batches in some regular intervals. Only these cross-chain transactions that need to have some priority when it comes to proving, that can also work, right? And that will present much lower overall load on the entire ecosystem, I would say.
Yeah, that's a fantastic point. So what you could imagine, for example, is the top of block or top of blobs have like 2 or 3 like super high value transactions, which are synchronous. And then everything else, the 99% of the block is just like asynchronous stuff, which is super cheap, for which the proving can be delayed to the next block.
Exactly. Like in a traditional banking system or financial system, you can pay a little bit more if you want your transaction to go through immediately. Like this priority transaction, you pay a little bit higher fee and your transaction goes immediately. Otherwise, you wait for the settlement. And in this case, settlement will be in 20 minutes or 15 or whatever. Otherwise, it will happen immediately. Yeah. Okay, cool. That was a nice discussion. Let's move, in the interest of time, let's move forward to identity. I would like to pick your brain already here. I know you're focused on ZKVM mainly now, and that's your only focus, but you are familiar with the concept of course, the decentralized ZK-powered identity, and if you can just basically shed some light on the use case.
Yes, I mean, identity, we were been talking a little bit about before, but at the end, I mean, identity is what you know about the others and what the others knows about you. Okay, this is what defines this identity. Or this information, we can call them claims, okay, or they can be piece of information that actually you know about. So at the end, in identity is, well, when you want to share this information, when you want to prove something about your information, this is where the ZK makes a lot of sense. At the end is you are asking somebody about some information, the other person is providing you to that information, and it's proving to you that information. And here, I mean, issuers can be individuals, but can be governments, can be companies, can be any authority. There's authority, and the recipients of these claims can be individuals, but I mean, individual can have different identities, or even a bot or even an object can be their own identity. Okay, so at the end is having for me, identity is at the end is a system. It's a huge database of claims where each individual holds part of this information, and then you are doing queries on this database, this decentralized database, making queries and proving that these queries are valid. I mean, this is the base for I understand as an identity system. And of course, here zero knowledge is in the core of the technology. I mean, an identity system without zero knowledge. I'm not even sure if it's, I mean, it's possible, but then you lose this privacy, you lose this control of which part of your information you are giving away.
Yeah, absolutely agreed. And again, that privacy, as Bomin explained previously, and you, Jordi, also is, in lack of a better word, compliant privacy, even though some people might not like this word, but really the properties of ZK allow full privacy towards the entire world, pretty much, and you still can comply with anything you want to comply with. You can disclose any portion of the data that is kind of hidden by zero knowledge cryptography, etc. So it's still possible to have I would say realistic mass adoption. Because I think that kind of cypherpunk, full-blown privacy world is utopian one. I would say maybe some people will disagree, and I think it's probably for the better, to be honest. But this is some philosophical debate now. Anyways, long story short, ZK as a technology allows implementation of identity protocols that are fully private, yet allow you to disclose any portion or any kind of information held by your identity account or storage to any party that you want. So that's a very important property, I guess. Okay, and I would just like to ask everyone if you have, let's go beyond all these use cases and challenges. If you have anything that we haven't mentioned here, for example, I remember just in reading those Medium posts from whatever 2017, when I used to read everything I could get my hands on ZK related. You were mentioning some interesting, crazy ideas, having Ethereum with only a single opcode that verifies ZK proofs and remove all the other opcodes and whatnot. So anything, guys, that you want to maybe bring up that comes to your mind that can be some additional use case or implementation of ZK?
Here, probably I would like to mention one of the applications that I think that we will hear a lot in the coming years, and is the multi-party computations. I mean, if you understand ZK as you are an individual, you have some data, and you want to process this data, and then you prove that this process is valid. So here, imagine that instead of being a single individual, you have like many individuals that they want to do a computation, and you want to compute a result, but that comes from information that comes from many individuals, and you don't want to share these individuals. You want to keep this zero knowledge preserving there. I think this is an amazing idea and an amazing technology. ZK is again a fundamental piece for all these kinds, and this allows individuals to have this shared knowledge. I mean, it's just without revealing your information, you can know something that's like the aggregation of all the data of many people here. So here, a lot of applications will come on that, and I think this is a really cool technology that we will hear more in the coming years.
Okay, thanks, Jordi. Justin, can we have Ethereum with only one opcode?
Yes, and in some sense, we are moving towards that future, right?
So you saw it 5 years ago.
Well, actually, I had completely forgotten that I wrote about this. And Vitalik is very interested nowadays in massively simplifying the execution layer down to one opcode. But even in terms of things that we have planned, is to snarkify the EVM. And basically, from the point of view of a validator, you just have to verify this one snark. But what we can actually go much further, which we can create a ZK EVM verification opcode within the EVM, so that if you want to deploy an EVM equivalent rollup, you can just benefit from this one opcode. So instead of building some sort of crazy multi-prover, multi-verifier ZK EVM, you can just use this one opcode. So that should dramatically lower the barrier to entry to building a ZK EVM equivalent rollup. But it has actually another superpower, which is that it stays equivalent as Ethereum hard forks. So let's say that if Ethereum makes a change to the EVM, well, now if you want to be EVM equivalent, how do you update your circuits? And like the only way that I know for rollup today is to use governance. But unfortunately, governance, if it has the ability to modify the circuits, that's an attack vector, because someone can take over all the tokens and then make a vote which will just change the circuit in such a way that all the funds go to the attacker. And so with this one opcode, we can remove the need for governance on execution specifically. And then another really cool aspect of this is that if there is a bug in the circuits, and there will be bugs for some period of time, then the layer 0, the social layer, can fix it. So we can update our clients. On the other hand, again, like if you have a critical bug, you're going to need governance to go ahead and fix it at the rollup layer.
Mm-hmm.
Would having that single opcode require to enshrine some proving system, or can it be done in such a way where there is no enshrinement?
Right. That is a good question. So one of the really clever ideas by Vitalik is that the proofs are actually off-chain. So they're kind of gossiped at the peer-to-peer layer, and they only affect the fork choice rule. So let's say that there's 5 clients, execution clients. For example, Gef has a prover, and it has its own kind of Gef snark, and that gets broadcast. And then as a validator, I kind of choose what proofs I'm going to listen to. And if it happens that Gef snarks have a bug, well, I can now update my client and run the ref snarks. And so the cool thing here is that you can have the client diversity at the fork choice level without enshrining any specific circuit or any specific prover for this one opcode.
This is very cool. Okay, they are warning us that we have only a couple of minutes left. So yeah, just to wrap up what we have covered so far, even though I was joking in the beginning that this statement is controversial, I think at this point there is general opinion or rough consensus in the industry that ZK is the end game. And as we have covered on this panel, there is indeed no other technology that can solve all these challenges, address all these use cases like scaling, privacy, interoperability, decentralization, identity, etc. So it really is a fascinating and I would say critically important technology. I would like to hear from you guys 2 things. One, why it might not be the end game. What can go wrong possibly in your mind? And because we don't have time for another round after that, if you can share any closing thoughts in regards to that or anything apart from that. So yeah, these 2 things. Uma, over to you, please.
Yeah, I think maybe in general, like the social layer of Ethereum and like the ecosystem needs to emphasize more that like security actually matters and things like that. I think one thing that could be really bad is if one day there's this like something bad happens and there's this like catastrophic failure of like systems that aren't secure, and then everyone realizes, oh, in hindsight we should have been using ZK but we weren't. And I think it's like important to kind of preempt that and encourage people to like have security and like, pay for security and, go through a little bit of extra work before we have something that like makes it really, really obvious. And yeah, I think the ZK tech, my closing thoughts are just the ZK tech is, I feel like pretty ready, like inexpensive and rapidly getting cheaper today. So hopefully we see that future sooner rather than later.
Fully agreed. Excited for that. Toggle, do you want to go next?
Yeah, I actually wanted to follow up on what Uma said. I think the ZK tech is almost there, and we're at the point where we can use things that were difficult to imagine a few years ago. I remember having a conversation in early 2021 with someone whom I really respect, and there were just rumors going around that Jordi is building an EVM compatible EVM equivalent ZKVM, and that person said that Jordi is insane. It would never be possible to do that. And here we are, just 3 years later, and there are multiple ZKVMs on mainnet that are almost or entirely EVM equivalent, and it's just and the technology just keeps improving. So there are still things that we can improve that will allow what Justin describes in terms of synchronous composability, etc. But it's been an insane few years to be involved in terms of how much the technology improved. And
For sure. Justin, you want to go next?
Yeah, I'm also excited by the commoditization of snarks because it means that they can be used as a primordial building block in the rest of cryptography. So snarks are very useful in MPCs and FHE, and they're also useful, for example, if we want to do post-quantum signatures, right? Like one very easy way to do a post-quantum signature is to have a stock of knowledge of some sort of a hash image. And you can also use Snox for aggregation of signatures, and that's one of the big problems that we're faced right now at L1 is, how can we very, very quickly aggregate 1 million signatures? And I think Snox can provide an answer there. And also Snox are used for like this crazy futuristic cryptography, like witness encryption and IO and one-shot signatures. It's always a building block in these constructions, and I'm hoping that they become as commoditized as hash functions, which are also used everywhere.
Okay, awesome. Bobin, do you want to go next?
Yeah, so I think why ZK might not be the end game, like I can think of a couple of reasons, but none of them are the reasons like which put us in a world where probably would be pleasant to live in. Like one is maybe there's like some fundamental flaw that is found in cryptography that affects like all ZK proving systems, and in that case, I think we have much bigger problems, and it's not just ZK related. And probably a very unrealistic scenario, but then again, if that happens, it's like not going to be a fun world to live in. And the other way is like more on the social side, where for whatever reason, similar how like encryption was considered to be too like sensitive to be handled by mere humans, like maybe governments will decide to ban use of ZK for some, like because you can do various things, and maybe it will get criminalized or something like that. And again, this would not be the world that I want to live in if that happens. But like aside from like this extreme unlikely scenarios, I can't imagine like why ZK would not be the end game for at least for blockchains and probably many other applications as well.
Okay, awesome. And Jordi, why it might not be the end game, and what are your closing thoughts?
Well, yeah, I just want to express a little bit a concern that I have. I mean, it's a bit, besides security, or even extending a little bit beyond security. I mean, I remember at the beginning of the blockchain, when somebody just sent a smart contract to Ethereum, there was at least 10, 15 persons or 20 persons that verify that smart contract, that reads a smart contract, and that verifies that actually this smart contract was doing what actually they were claiming to do. This does not, I mean, I don't see this spirit anymore. And even the ZK, in the ZK, I mean, these systems become more complex, and verifying all these becomes even much more difficult. But if we build a system that's a trustless system, okay, that means that we don't need to trust. We should, and in order to trust, you need to check, you need to verify what's in there. And a little bit is just express the concern that if we are not verifying the systems, if we are not understanding, if we don't have people that just checking what's behind, this can be problematic. Here, I mean, a huge shout out, for example, to Yuma's work on all these systems. I think this can help a lot, because at the end, they're simplifying a lot the source code of the actual prover itself. I think this is a good direction to go that, but even that, I mean, verification is important, verifying that what you are doing is correct, and this is responsibility. We don't have a central authority that's going to do that. I mean, this is responsibility of all the peers in the decentralized systems to verify that what we are running actually is correct.
Makes sense. Okay, guys, we have to wrap up this one. Thanks a lot. I have really enjoyed this conversation, and thanks, Master Hudson, for not kicking us out earlier and allowing us a few extra minutes. Yeah, that's all. Thanks, everyone.